Welcome back to my YouTube channel. In today's video we will see about the topic alpha beta pruning. Alpha beta pruning, we can say it is a modified version of min-max algorithm, and we can also say that it is an optimized form of min-max algorithm. What is the optimized form means? Here the drawback of min-max algorithm, which is visiting the all nodes, that is the main drawback of min-max algorithm. So that is overcome with the help of this alpha beta pruning. So that's why it is called as optimized form of min-max algorithm. Then we are new with the term pruning. So pruning generally refers to the meaning removing. So here pruning it indicates that we can discard the nodes without exploring it completely. So how we will be pruning? With the help of one condition only we will be checking whether we can eliminate that node without visiting or not. That we will see in the next few minutes. And here we are making use of two threshold parameters. One is alpha and another one is beta. And alpha we call it as maximizer and beta we call it as minimizer value. And we are initializing the alpha value with its worst case value, which is minus infinity, and beta with the value infinity. And here it makes use of the depth first search strategy, DFS. So the time complexity and the space complexity of alpha beta pruning is same as that of DFS, which I have stated here, which is order of B per M and order of B into M. And here some other conditions to be noted are max player can update only alpha value, and min player can update only beta value. Apart from that, we should be knowing that normally alpha and beta values will be passed from parent to child. When there is a parent, when we are passing the values, normally alpha and beta values will be passed from parent to child node. And while performing backtracking alone, current node's values will be updated to its parent node. Current child node's values will be updated with the parent node. So this is what the description about alpha beta pruning. And here we will see with one example the implementation of alpha beta pruning. And I have one graph here. With this graph I will try to explain the working of alpha beta pruning. Initially I will initialize the initial value with minus infinity and infinity. So that will be passed here also, minus infinity comma infinity. Then here also minus infinity comma infinity. As we know, we will be naming the levels at max, min and max, and the end nodes which has no child, we will be naming it as terminal nodes. So first we will check the at this level max value will be updated, maximum value will be checked, and we will be updating only alpha value. This one we call it as alpha and this one we call it as beta. Okay, so that's how we will update. Then when comparing the alpha values, which is minus infinity and 2, which is maximum, means 2 is maximum, so we'll update it with 2 comma infinity. So the value will be updated as 2 comma infinity. Then here we will check alpha is greater than or equal to beta. So I forgot to tell one thing, when the condition for pruning should happen. When we can perform pruning means when alpha is greater than or equal to beta. If this condition is satisfied, then we can perform pruning. Here you check whether 2 is greater than or equal to infinity, condition false. So again we will be moving with another child node, which is 3. So 3 we will be checking either 2 or 3, which is maximum. 3 is maximum, so we'll update this value with 3 comma infinity. So this will be updated value. Again we will be next, it has another node to be explored, so we will be updating here. This level we got a minimum has to be checked. So minimum value is beta value. So beta, when compared to alpha, infinity, 3 and infinity, which is minimum, it is 3, so it will get updated like minus infinity comma 3 will be updated here in this level minus infinity comma 3 will be updated. So here we cannot touch alpha because this is a min level, and here only alpha beta can be changed. So that value will be passed here, which is minus infinity comma 3 will be passed here. Okay, at this level. Then we have to check the maximum value 5 and minus infinity, which is maximum 5. So 5 we will be getting 5, the updated value will be 5 comma 3. Now you can check alpha is greater than or equal to beta, which is 5 is greater than or equal to 3, condition true. So this node can be pruned. Without visiting we can discard this node. Okay. Then comes the minimum value. So again the from 5 comma 3, which is minimum, that should be updated here. Already beta has to be updated in this level. So here we got 3, and here 5 and 3, which is minimum, again 3. So already it got 3 only, so no problem. Again comes this level. So here max value has to be updated. So when compared to here, we have to check only alpha value. So minus infinity 3, which is maximum, definitely 3. So it will be updated as 3 comma infinity will be updated. Okay, so that 3 comma infinity will be passed here and here also. 3 comma infinity will be passed here. Then at this level max value has to be checked, will be checked. So 0 and 3, which is max, 3 is maximum, so already 3 only is there, no problem. So next 1 has to be checked, 1 and 3, which is 3 is maximum, so it will be maintained as it is. So here minimum value has to be checked. So here you can see when compared to infinity, infinity and 3 is minimum, so it will be updated to 3 comma 3. So again you can see that 3 is equal to 3, so condition becomes true, so we can prune this tree here. So without visiting the exploring these nodes, we can prune here itself. By pruning this, automatically we are discarding this also, these nodes, these child nodes also we are pruning. So this is the working of alpha beta pruning. Thank you.